Hello and welcome back. So in the previous video, we learned how to send characters through the UART peripheral. And there is one problem that I should have mentioned to you. And it is the fact that this function call here, the UART pull out, this is what you basically call to instruct the peripheral to send out a character to whatever is on the receiving end, right? Now, the challenge with this function is that it is blocking. What it means is that until the byte, and remember, characters are bytes, the ASCII, remember ASCII coding. So every character on your keyboard actually has an ASCII code. And so when I say I'm sending the character Z, it is not the character Z that is transmitted on the wire. It has no capability of doing that. There is a binary representation of the ASCII code of the character Z. That is what is transmitted over the wire. You will see that on the oscilloscope very soon. In the next video. However, this function is a blocking call. So what it means is that until that character has actually been written out fully onto from the peripheral, your CPU or your processor is blocked from doing anything else. Remember at the start, I mentioned that there are different ways of doing this UART communication. It could be polling, or we could use interrupt, which is also something we talk about in the future video in this same section, right? So this is blocking, and that is the challenge with this UART pull out. So before you use it, ask yourself, is it a problem for my firmware if sending out information over UART blocks the CPU from doing anything? If that is not, then these APIs, as I have shown you, are okay for you to use. Otherwise, you would have to look into using the interrupt driven approach. Now in this video, I want to show you how you can receive information, right? Remember that I mentioned earlier that UART communication could be between an MCU and an MCU and a sensor, MCU and a host computer. You have seen that setup, that the MCU was sending the character Z and my host computer received and displayed it. The communication can also happen in the reverse direction. So we are going to learn how I can send something from my host computer and the MCU is going to receive that, okay? Now, you might ask yourself, how do we send? Well, every terminal program, and there are different terminal programs out there. At least I know of PuTTY. If you are on Windows, you might want to check out this software. It helps you to do terminal emulation, but I am okay with what's in my VS Code. There is also Realtem, I believe. Yeah, Realtem. So there are quite a number of terminal emulators that you can use on Windows, but I am totally okay with what I have in VS Code, so that's why I'm not switching to any of those. Now, you see down here, there is a way for us to send information. Let me just start monitoring so it keeps receiving. Now here, I can send information. And when you are sending information from the host computer, then it means it is the MCU that is going to receive it. So in a future video, we can actually build a firmware where I can type a number here to determine what LED on my board should be lit, right? So I can send it 1 and it can light LED 1. I can set it 5, it can light LED 5, basically. In the same way, we can send any piece of information. You can actually send as text, or you can come here, you can send as hex, you can also send as binary. I'm going to show you how to send as text in this video. So let me stop monitoring and let's modify the code to do that. So I just want it to be a firmware that echoes what it receives. So it basically receives a character on the UART connection and it sends back the same character. Okay, that's basically what an echo software does, right? To do that, I'm going to maintain this program. Like a larger chunk of it is going to be maintained. I'm going to declare a variable and I'm going to call it received, and it's going to be empty, right? No character in there. And then down here, I will first of all call a function. There is this function called UART poll in. So to send out, it is UART poll out. And to receive, it is UART poll in. And the poll is to remind you that you are using it in polling mode, right? So I'll say UART poll in. Look at it here. Let's see the signature of this function. I don't know why IntelliSense is super slow for me. All right, so UART poll in basically takes a pointer to the peripheral or the device that we have created and a pointer to a character that it should store whatever it receives into. So let's come here, and then I'm going to give it UART, which is what we have defined up here. And then now we need a reference or a pointer to this character. So I'm going to do RCV. But we are not done yet. This UART pool in function, where is it? Yeah, it returns an integer. And that integer it returns tells us whether it received something or not. Now, unlike the UART poll out, which is blocking, the UART poll in function is not blocking. So when you call this UART poll in, the MCU is just going to check, is there data available for me to read over UART? If it is, it reads. If it is not, it will indicate with the return value that, dude, I checked, there was nothing, so I'm continuing the program. But if it checked and there was something, it resets into the UART buffer and it's available to you in your program. So this UART poll in is not blocking, but UART poll out is totally blocking. Keep that in mind. So we have to be interested in checking the return value of whatever this function brought in, right? So we already have int ret here, so I'm going to reuse it. So this is going to store the return value of this function call. Then we have to check if return, if whatever was returned is not equal to -1, then it means that some character was actually there. It brought in some character, and then now we can write back that character. Okay, and so I will just use UART poll out, and then I'm going to give it UART, and then I'm going to give it the character that we received. Basically, this is it. Now the UART poll out, IntelliSense keeps failing me. You see, it doesn't return anything, but it's a blocking call. Remember that. So what is left here? Maybe just a little KM sleep, so we don't overburden the system unit. I'm sorry, the CPU. So I'm going to compile this code once again. Empty character constant, blah blah blah. Well, I can choose not to. Maybe this. And it has compiled. So I'm going to upload this code to the board. All right, upload is done. Let's clear the terminal's console and let's start monitoring. So you can see that unlike the previous program where we kept spitting out the character Z to the UART connector, this time nothing is coming until we send something. Remember, this is an echo firmware, so it basically sends back what it received. It's as simple as that, right? So I come here, I type in, let's say, A, and it sends back the A to me, right? If I send, let's say, B, it does the same. If I send the character 1, it echoes it back to me. So you can see that, first of all, this one is not part of our firmware. It's the terminal program telling us that it sent a UTF encoded message A. And this one is what is telling us what we have received and that we've sent back. Okay, so this one is the terminal program You wouldn't see this in every terminal, but this particular terminal in VS Code happens to print out information that tells you what it sent, right? And then remember that on line 28, we do pull out of whatever we received. And so that is what appears after each sending is done. So this is how you can receive in polling mode. Now, with these two videos that you have watched, or two lectures that you've had on UART, you should be able to build a firmware that receives sort of some commands over UART and lets the MCU perform something. I will do that with you as an exercise, but it will be good if you did it as a homework. So basically, try to write a program where you send a number. It depends on the number of LEDs that you have on your board, but you send a number and use that number to determine which of the LEDs to turn on your board. And I guess this is it for this lecture. Thank you very much for watching this, and I will see you in the next video where we talk about the details of the UART protocol using an oscilloscope. Thank you, and see you then.